All right, guys, for today's lesson, we're going to need page 181, okay? Page 181 to 182 and 183 out of their workbook. Okay, so looking at page 181, today's topic for lesson 8, session 2, is showing that the slope of a line is constant. Okay, so the problem starts off with a delivery company uses robot dogs to deliver packages in an office building. The graph shows how long a robot dog can operate for each hour its battery is charged. So over here we see the graph. We see the charging time in hours. We see the operating time in minutes. Okay, it says pick any 2 points on the line, find the slope of the line between these 2 points. And then they ask, can you find another pair of points on the line that gives you a different slope? All right, so we're going to go ahead and turn to page 182. And up at the top there, it's just the same restating the problem. And we go down below to the model it. Okay, so the model it says you can use translations of right triangles to help you solve this problem. So we're familiar with translations from doing our transformations unit. It says choose any 2 points A and B on the line. So here is A and here is B. It's important that you pick points that go through the corners of a box, okay? So we see these 2 points definitely go through the corner of a box. They're not like on the side of the square or halfway through it. They are exactly on the corner of the box. And then it says draw segments for vertical and horizontal distances between the 2 points. So my vertical distance would be this spot right here, and then my horizontal distance would be that. Okay, so let's go ahead and label that. So this was our vertical distance, and then this one down here was our horizontal distance. Okay, and then it says you can translate this slope triangle along the line to compare the slope between different pairs of points on the line. Okay, so that was for this triangle we created here, A, B, and then we made this point down here, E, to make a right triangle. Now we can repeat the process. We can use point B, and the next point I see I can do is point C here. It goes through the corner of a box. Okay, and again, I can go ahead and do the vertical distance, create a point F there, and my horizontal distance. I'll see that it is the same measure. Okay, and then we can also repeat from C to D. Same thing, vertical distance to point G, and from C to G, there's my horizontal distance. And all these triangles are going to be congruent. Okay, we're going to go ahead and turn the page. And it says number 1, look at the first model it. Okay, are triangle ABE, BCF, and CDG congruent? And so again, there's that word congruent that keeps popping up. And it says, how do you know? Well, we know they are congruent. So we're going to say yes. Remember, congruent is same size, same shape. So let's say yes. They are the same size. If I look at the triangles here, this side here, we have 3 units. This side here, we have 2 units. Okay, and then we see this distance, diagonal distance, all appears to be the same length. Okay, same size, and it's the same shape. So it's all right triangles that we made. And then it says, well, more so, how do you know? Well, if we look here, we can take this triangle, and we could do some transformations to move it onto this triangle. So we could do a sequence of translations, perhaps move it to the right and then up so many units, or move it up and then to the right so many units. So we could say you can perform rigid transformations to move one triangle on the other. All right, so we can move one triangle onto the other one there. Okay, letter B. How can you use triangle ABE to determine the slope of the line between A and B, and what is the slope? Okay, so the important thing for the slope that we're going to look at today is looking at these vertical distances and horizontal distances. So let's go ahead and write this down. So we want to take the vertical distance and place it over the horizontal distance. Okay, and this is going to give us our slope. So if I look at A and B, my vertical distance, okay, if I look down here and I got to go all the way up to there, I see that's actually 1, 2, 3 squares. But I got to be careful with this because one square isn't worth just one. If I look over here, it's my operating time in minutes. And I see that each square is going to represent 10 minutes. So 3 squares, so there's 10, 20, 30 minutes. Okay, so my vertical distance, I'm going to write 30 minutes over the horizontal distance, and I see 0 and all the way to 1 here, but it takes 2 squares to get there, but still 2 squares to get there is equal to this 1. So 30 minutes, and it's 1 hour. Okay, and I should probably put in here 30 minutes of operating time. So our slope for this would be 30 minutes for every 1 hour, meaning the dog can operate for 30 minutes for every 1 hour that it's charged. Okay, problem C. Is the slope of the line between points A and B the same as the slope between B and C, as well as between C and D? Explain. So it's asking you, is the slope of this side equal to the slope of this side, which is equal to the slope of this side? And we could say yes, because the figures are congruent. All right, we already talked about before how we could do various transformations to move these objects onto each other, to map them onto themselves, and doing so, we learn that they are congruent. Okay, number 2, look at the second, model it. What is the slope of the line between points A and B, and then between A and D? So down here at this one that we initially skipped, they want to know, first off, what's the slope between the points A and all the way up to B? Okay, and then we're going to treat this the same way. So this is my large triangle I'm making right here. All right, so what we want to do is we want to go ahead and do the same thing, do our vertical distance over the horizontal distance. Okay, so to set up this problem here, let's go ahead and look at the vertical distance. And so straight up and down of this big triangle right here. And if I'm looking at this one, starting at 0 down here, it goes all the way up to point B here, which is going to come over here and represent 90 on the y-axis. So my vertical distance would be 90. And again, this is operating time in minutes. So 90 minutes of operating time over the horizontal. So all the way out here, we see that all the way from 0 to 3. So that's 3 hours charging. Okay, so 90 operating time over 3 hours. The next thing I want to do is I want to look at the problem and see, can I reduce it? So can I make that fraction smaller? In this case, yes, because we know 3 goes into 90 evenly. So let's go ahead and reduce that. So 3 goes into 90 how many times? 30, because 90 divided by 3 is 30. And then 3 divided by 3 is 1. So I get 30 minutes for every 1 hour of charging. And if we notice, that is the same thing that we came with up above there. So we got the exact same slope. We know those segments are the same there. They're congruent. Okay, number 3. Both models started by choosing points A and B. How do you know the slope of the line is the same between any 2 points on the line? We could say this. It doesn't matter which points you choose, because it will reduce to the same amount. Okay, meaning if I'm looking at point A to B there, make this big triangle, that's going to be the same thing as then if I chose this smaller triangle here, A, D, E, for example. If I was to look at this one, my vertical distance right here, 0 to 60, so that'd be 60 there, over my horizontal distance, 0 to 2. 60 to 2 would reduce down to 30 to 1. So we see that number popping up at all the previous problems. So again, it doesn't matter which 2 points we pick. If we put them into this equation with the vertical distance over the horizontal distance and simplify, it's going to be the same slope. Okay, that is it for today.